Aston Martin may be sitting on a 40 horsepower breakthrough that could completely change its Formula One future. The claim is explosive. A major Honda engine gain, a potential Zandvoort arrival, and leaked data supposedly pointing toward a sudden performance jump. But there is one problem. The available source does not actually reveal the data. It gives no test figures, no technical breakdown, and no confirmed link to Zandvoort. It only presents the 40 horsepower claim in the headline. So either Honda has found one of the most important gains of the new era, or Aston Martin is being surrounded by expectations that the evidence cannot yet support. And the real question is not whether 40 horsepower sounds impressive. It is whether Aston Martin can turn that claimed gain into acceleration, reliability, and lap time when the car finally reaches the track. Because if the answer is yes, the balance of power could shift faster than anyone expects. Subscribe to the channel. To understand why this claim has attracted so much attention, you have to separate the number from what the number could actually mean. 40 horsepower sounds decisive. It sounds like the kind of gain that could instantly move Aston Martin closer to the front. But Formula One does not reward impressive numbers by themselves. It rewards complete performance. The available source presents the 40 horsepower figure in its headline, but it does not include the leak data mentioned in the title. It gives no test conditions, no comparison point, no technical breakdown, and no confirmation that the gain will appear at Zandvoort. And that missing information is not a minor. It is the most important part of the entire story. Because 40 horsepower compared with an older engine specification would mean one thing. 40 horsepower compared with an early development target would mean something completely different. And 40 horsepower measured briefly under controlled conditions might not represent what the driver can use throughout an entire Grand Prix. That is the first question Aston Martin would need answered. Is this peak power or usable power? Peak power is the highest output an engine can produce under a particular set of conditions. Usable power is what the driver can call upon repeatedly, without creating unacceptable heat, excessive wear, or reliability concerns. Imagine a person who can sprint extremely fast for 5 seconds. That speed looks remarkable. But if the challenge lasts 2 hours, the more important question is whether that person can maintain a strong pace without collapsing. A Formula One power unit faces the same basic test. One impressive run proves potential. A complete race proves performance. And this is where Honda's alleged gain becomes far more complicated than the headline suggests. More power can improve acceleration. It can help the car reach a higher speed earlier on a straight. It can give the driver a stronger opportunity to attack before the braking zone. But that extra output must travel through the complete car. The gearbox must handle it. The rear tires must transfer it to the track. The cooling system must control the heat. And the driver must receive the power smoothly enough to remain confident. If one of those areas cannot cope, part of the advantage disappears. Think of trying to pour water through a narrow pipe. It does not matter how much water is available at the beginning. The pipe controls how much reaches the other side. Honda may create the power, but Aston Martin's complete package determines how much of that power becomes lap time. That is why engineers would not react to the 40 horsepower claim with celebration alone. They would ask where the gain appears. Does it arrive at lower engine speeds, helping the car accelerate out of slow corners? Does it appear near the top of the operating range, improving performance at the end of a straight? Does it come from the combustion side of the power unit? Does it come from electrical deployment? Or does it represent a combination of several developments? The source does not answer those questions. Without those answers, nobody outside the project can know how dramatic the real advantage would be. And there is another hidden issue. The way power arrives can matter almost as much as the amount. A sudden burst may overwhelm the rear tires. A smoother delivery may allow the driver to press the accelerator earlier. That earlier acceleration can create an advantage that continues all the way down the straight. The difference may begin with only a fraction of a second. But Formula One races are built from fractions of a second. A small improvement at one corner can become a larger opportunity at the next. That is where the claimed gain could become genuinely valuable, not because the engine produces a dramatic number, because the driver can use that performance at exactly the right moment. But Zandvoort adds another layer of uncertainty. The available source does not confirm that an upgrade is scheduled for that race. It does not provide a deployment plan. It does not identify a date. And it does not include a statement from Aston Martin or Honda connecting the claimed gain to the circuit. So the Zandvoort link must remain unverified. Still, the idea creates an interesting test. Zandvoort is not a circuit where raw engine output automatically solves every problem. A car needs balance. It needs stability. It needs grip through demanding corners. And it needs a driver who trusts the machine enough to carry speed without hesitation. Extra power could help during acceleration. But if the car struggles to transfer that power to the track, the benefit becomes limited. Imagine trying to run faster while wearing shoes with poor grip. Your legs may become stronger, but every harder step increases the risk of slipping. The same principle applies when a racing car leaves a corner. The engine can produce more force. The tires must accept it. If they cannot, the driver has to wait before using the accelerator fully. And that delay can erase the advantage Honda worked to create. This is why Aston Martin's so-called breakthrough would depend on integration. The power unit cannot be treated as a separate weapon. It must become part of a complete system. The suspension must help keep the rear tires connected to the track. The aerodynamics must keep the car stable as speed increases. The cooling design must protect the engine without creating too much drag. And the software must manage the delivery so the driver receives predictable performance. Every part affects the next. More power can create more speed. More speed increases braking demands. Braking changes tire temperature. Tire temperature changes grip. And grip determines how early the driver can accelerate again. The process forms a circle. That is what most people miss when they see a horsepower figure. They see the beginning of the chain. Engineers have to manage the entire chain. And this is where the pressure on Aston Martin becomes serious. A claim of 40 additional horsepower creates expectations before the car proves anything. Fans begin imagining stronger qualifying results. They imagine easier overtakes. They imagine Aston Martin suddenly challenging teams that previously seemed out of reach. But expectations can become dangerous when the evidence remains incomplete. If the car improves, the number will receive the credit. If the car does not improve, people will question whether the gain ever existed. The truth could sit somewhere in between. Honda may have found genuine performance. Aston Martin may still need time to unlock it. The engine may be stronger. The car may require different cooling, setup, or energy management before the full benefit appears. And the team may choose not to use the most aggressive settings immediately. That would not necessarily mean the claim was false. It would mean the project was unfinished. Formula One development rarely arrives as one perfect step. A new idea works in one condition. Then another condition exposes a weakness. Engineers solve that weakness. The solution creates a new opportunity. And that opportunity produces another question. This is why the missing data matters so much. Real data would show where the improvement exists. It would show whether the gain is repeatable. It would reveal how the engine behaves under sustained load. And it could indicate whether Aston Martin is looking at a dramatic transformation, or a promising number that still needs to become reliable performance. Until those details appear, the 40 horsepower claim remains exactly that. Lame. A powerful one. A potentially important one. But not yet the proof of a Zandvoort breakthrough. And Aston Martin's biggest challenge is no longer creating excitement. It is turning that excitement into something the stopwatch cannot deny. And this is where the pressure moves away from Honda and lands directly on Aston Martin. Because even if the claimed 40 horsepower gain is real, the engine cannot prove the story by itself. The car has to reveal it. That means stronger acceleration must appear without destroying traction. Higher speed must arrive without forcing dangerous cooling compromises. And any increase in performance must survive long enough to matter on Sunday, not just for one dramatic qualifying lap. This is the point where a promising engine figure becomes a complete Formula One problem. Honda could deliver more output. But Aston Martin still has to decide how much of that output the car can safely use. And that decision is much harder than simply turning the engine up. A Formula One power unit operates inside strict limits. Heat must be controlled, energy must be managed, components must survive repeated stress, the driver must receive predictable power every time the accelerator is pressed. If the team becomes too aggressive, reliability can suffer. If it becomes too cautious, the supposed advantage may remain hidden. That creates a narrow target. Aston Martin must release enough performance to make the upgrade meaningful, but not so much that the engine begins damaging the rest of the project. Think of walking across a frozen lake. Move too slowly and you never reach the other side. Move too aggressively and the ice may break beneath you. The safest path is not always the fastest one. And in Formula 1, finding that balance can take time. This is why the first appearance of an upgrade does not always reveal its full potential. The team may begin with conservative settings. Engineers may study temperatures. They may compare acceleration traces. They may check whether the tires can handle the delivery. They may look for vibration, unusual wear, or unexpected stress in surrounding components. Only when the data looks safe can they begin releasing more. That process can be frustrating for fans. A major claim creates the expectation of an immediate transformation, but development rarely works like a light switch. It is more like opening a locked door, one careful movement at a time. The first turn proves the key fits. The second proves the mechanism moves. Only the final turn opens the door. And Aston Martin may not know how far it can turn that key until the car faces real track conditions. That is why the supposed Zandvoort connection creates such intense curiosity. If the upgrade really appears there, the circuit could expose both its strengths and its weaknesses. Zandvoort demands commitment. The driver needs confidence to fast direction changes. The car must remain stable over elevation changes. The rear tires must deliver traction when the racing line offers very little room for error. A stronger engine could help the car accelerate away from slower sections. But if the delivery is too aggressive, the tires may struggle. If the car begins sliding, temperatures can rise. If temperatures rise too far, grip can disappear. And once grip begins to fall, the driver has to wait longer before using the power. The advantage then starts canceling itself. This is the hidden battle behind every major engine improvement. The engine wants to release force. The tires decide how much force reaches the track. That means Aston Martin suspension and mechanical setup become essential. The rear of the car has to remain controlled. Weight must transfer smoothly. The driver needs to feel the moment when the tires are ready to accept more power. If the car communicates clearly, the driver can accelerate with confidence. If it feels nervous, hesitation appears. And hesitation is expensive. A driver may wait only a tiny fraction longer before pressing the accelerator. But that delay continues down the entire straight. One cautious moment at the corner exit can become lost speed hundreds of yards later. That is why power delivery matters so much. A larger number does not automatically create a faster car. A predictable response does. Honda's real achievement would not be finding 40 additional horsepower for a brief test. It would be delivering that performance in a way the driver can trust repeatedly. Lap after lap. Under changing fuel levels. Under rising temperatures. While following another car. While attacking. While defending. That is the standard that separates potential from a real competitive advantage. And there is another reason the full story cannot be judged from a headline. The available source does not provide the leaked measurements supposedly behind the claim. It does not explain whether the increase refers to the engine alone, the electrical system, or the complete power unit.